Hello everyone, welcome to ChemWorld. Today we will be discussing dimensional analysis. Dimensional analysis is a powerful tool in chemistry used to convert between units and solve problems involving measurements. In chemistry, dimensional analysis is used for converting between units, solving stoichiometry problems, ensuring equations make sense with the correct units, and avoiding calculation mistakes. Dimensional analysis teaches logical problem solving and prevents errors. It is not just about math, it helps you understand what you are calculating and why. In dimensional analysis, you multiply a given quantity by conversion factors. There is a one conversion factor given here. 1 inch equals 2.54 centimeters. This conversion factor can be written in two different ways. We use 1 inch as the numerator and 2.54 as the denominator. The other method is we use 2.54 centimeters as the numerator and 1 inch as the denominator. The steps for using dimensional analysis: first you identify the starting unit and desired unit. Then write down non-conversion factors. Set up the problem with units arranged to cancel and multiply through and simplify. Let's see, there is an example given here. The given unit is meters and we need to convert that into inch. Since there is no direct conversion factor, we are going to use two different conversion factors in this calculation. When you are doing dimensional analysis, always include units at each step and cancel units diagonally. If multiple conversions are needed, chain them together. So the first conversion factor here is 1 centimeter equals 10 to the power negative 2 meters, and we write it as 1 centimeter in the numerator and 10 to the power negative 2 meters as the denominator, since we need to cancel out these meters and meters. When you are done with the first step, you have your calculation with centimeters. Now you are going to convert centimeters into inch. We know 1 inch equals 2.54 centimeters, and in this step we need to cancel out centimeters. Therefore 2.54 centimeters we use as the denominator and cancel out units here, and you will get the answer in inch. Let's look at a problem. If a weightlifting barbell has a mass of 5 pounds, what is the mass in grams? Given mass is in pounds, we are going to convert that into grams. So we need the conversion factor between pounds and grams, which is given here. 1 pound equals 454 grams. So we can write this in two different ways. 1 pound as the numerator, 454 grams as the denominator, or we can write 454 grams as the numerator and 1 pound as the denominator. Let's look at the given number. So here it's 5 pounds and we are going to convert that into grams. Therefore we need the conversion factor, the numerator, in grams. So 454 grams at the top and 1 pound at the bottom. So when you use that in this way, the conversion factor, you can see pounds and pounds will cancel out. When you are doing these calculations, write the numbers with the units, then you can clearly see how you can cancel out the units and obtain the units you need. So now what you have to do is 5 multiplied by 454. When you do that, you get the answer 2270. This is in grams. We already talked about significant figures in my earlier videos. When you are doing dimensional analysis, you have to keep your significant figures correctly in your answer. So the conversion factors are exact numbers, therefore we do not count their significant figure, but we have to count the sig figs in the given number. So here £5 is the given number. 5, these two zeros are significant, therefore there are 3 significant figures. So your final answer should contain 3 sig figs. If you check the answer we obtained from the calculator, 2270, this 0 is not significant, therefore in this number you have 2, 2 and 7, they are significant. Therefore, the correct answer with correct significant figures is 2270. Let's look at another problem. The average speed of nitrogen molecule in air at 25 degrees C is 615 meters per second. Convert this speed to miles per hour. All the conversion factors are given here. In this calculation, there are 2 units you need to convert. If I write down the given number 615, which is in meters per second, what we have to do is we have to convert this into miles per hour. There are 2 different units that you have to convert, and there are 4 conversion factors given. You can start either with meters to miles or seconds to hours. It doesn't matter, but you have to do both. Let's start. Given number is 615 meters per second. If I start with meters to mile, the first conversion factor is we are going to convert meters into kilometers and then kilometers into mile. Since there are no direct conversion between meters and miles, we have to go through these 2 steps. So the first conversion factor here is we use meters at the bottom. So 1000 meters, to cancel out the meters, equal 1 kilometer. You can see meters and meters will cancel out. The second conversion factor is now you have kilometers, so 1.6093 kilometers equal to 1 mile. Now kilometers and kilometers will cancel out. Now you can see we have the distance unit in miles. The next conversion is seconds to hours. In order to convert seconds to hours, first we do the minutes and then hours. So if you take the first conversion here, the second is here as the denominator. Therefore, 6 seconds equal 1 minute. To cancel out the seconds and seconds. Then you have minutes as the denominator. So 60 minutes will equal 1 hour. Minutes and minutes will cancel out. Now you can see we are ending with hours as your time unit. Now we have already done the unit part. Now we have to do the calculation. Let's see the numbers we have. So in this calculation you have 615. At the top you have 1 times 60 times 60 divided by 1000, which is here, and then 1.6093 times 1 and times 1. So your unit is miles per hour. Now you have to do the math here. If you do the calculation, first you take 615, multiply that by 60 and then 60, divide by 1000 and divide by 1.6093. This gives you in the calculator 1375.75. However, now In order to get the final answer correctly with the significant figures, check the significs in the given number. In this, the given number here has 3 significant figures. So your final answer should also be in 3 significant figures. So if you round off this, there are 1, 2, 3, 4, 5, 6 significs. You have to drop number 5 here in order to get the correct significant figure. So you get 1, 3. Since you are dropping 5, you add 1 to 7 and make it 1380 miles per hour. That's your final answer with correct significant figures. In this case, the last 0 is not significant. 1, 3 and 8 are significant. Let's see how we can use unit conversion in this problem. The recommended dose of a drug that is used to treat asthma is 6.00 milligrams per kilogram of body mass. Calculate the dose in milligrams for a 187-pound person. Some conversion factors are also given to use in the calculation. What we need to do here is you are given the dose of this drug, which is 6 milligrams per kilogram of body weight. We are given the person's weight as 187 pounds. So we have to calculate how many milligrams needed for 187 pound person. If you know per kilogram, then if you know the person's weight in kilograms, we can multiply the dose by the person's weight in kilograms. However, the person's weight is given in pounds. So we have to convert these pounds into kilograms to get the body weight of the person. Let's start that way. So 187 pounds, we are going to convert that into kilograms. In order to convert that into kilograms, first you want to convert this into grams. Because there is no direct conversion between pounds and kilos, you have to go through grams. So 1 pound is equal 453.59 grams. That's the first conversion. In this case, pounds and pounds will cancel out, and then we are going to convert this into kilos. So 1 kilo equals 1000 grams. In this conversion, you can cancel out grams and grams and get the person's weight in kilograms. Do the math here. You have 187, multiply that by 453.59, multiply that by 1 and divide that by 1000. Will give you 84.82 kilograms. That's the person's weight. If we go with the significant figures here in the given number, 187 has 3 significant figures. Therefore, your answer here should be with 3 significant figures, 84.8 kilograms. Now, in order to calculate the dose in milligrams for this person, we know 6 milligrams is for 1 kilo. You multiply this by person's weight, 84.8 kilograms. That will give you the dose in milligrams for this person. So you multiply 84.8 by 6. That gives you 508.8, and you can see kilograms and kilograms will cancel out and you have the dose in milligrams. However, you have to still check the significant figures. So this one here, the given number 6 milligrams has 3 significs again, because 6, 0 and 0 all are significant. So your answer should contain 3 significant figures. If you round off this number here, 508.8, you will get 509 milligrams with 3 significant figures. This is one method you can do this calculation. Also, what you can do here, you can convert this dose 6 milligrams per kilogram into milligrams per pound, and then just multiply that by the person's weight given. So you can use either methods to calculate the correct dose for 187 pound person. If you have any questions, please mention them in the comment section. Thank you.